When combining the inductor and the capacitor, we have to remember that both of these components have the tendency to store energy. The inductor in form of a magnetic field and the capacitor in the form of an electrostatic charge. That stored energy is what gives these components their voltages. Now when looking at the series circuit, we remember that total voltage is the sum of all the voltages in the series circuit. However, because they are in opposite directions, we have to remember that their total, one of them will have a total that is actually greater than the total voltage because of the Q factor, which we will discuss at a later stage. So when current flows, our inductor and our capacitor, due to the storing of energy, will develop individual voltages across themselves. As current in both of these components is our reference, we draw the current on the horizontal. The inductor leads by 90 degrees, and the size of the inductor voltage will depend on the size of the inductor's reactance, which in turn is dependent on the size of the voltage frequency. The capacitor is the same, except it works in the opposite direction. Now when we look at these and we combine it, we see that VL and VC are in opposite directions to each other. As a result, depending on which one is bigger, we will subtract those two in order to get a positive answer. And that is where the formula V total is equal to VL, that wavy minus VC. That wavy minus just indicates that we're subtracting those two values from each other in order to get a positive answer. When it comes to the impedance diagram, we get the same, except we have XL at the top, XC at the bottom. Wherever our 0 point is, that's our reference, and we're subtracting those two from each other in order to get a positive answer. So in an LC circuit, Z, or the impedance, is equal to X total, which is the total reactance in the circuit, and that is equal to XL, wavy minus, XC. Remember, the wavy minus, we're subtracting the two values from each other in order to get a positive answer. So if the inductive reactance is greater, we're going to say XL minus XC. If the capacitive reactance is greater, we're going to say XC minus XL. It's important that this answer must always have a positive value. When placing an inductor in parallel with a capacitor, and that in parallel with a total voltage supply, we know that the total voltage is the same on both components. We also know that the current is going to lead and lag depending on which branch we're looking at. So that total voltage is going to separate or cause a current, which is going to cause a separated capacitor current and a separated inductor current. Together those two will form my total current. But we have to remember that as this one charges, it stores the current, and as it discharges, it generates a magnetic field on the inductor. With all LC circuits, the inductor and the capacitor is trying to operate in harmony with each other. In other words, it is trying to store charge at the same rate as which it is releasing it. So looking at these, my voltage now is the reference, the inductor has a lagging current and the capacitor has a leading current, and those currents are going to be determined by the reactances of the inductor and the capacitor. So when we combine those two, we're going to find again that they are in opposition to each other, IC versus IL, inductor current versus capacitor current, and that in effect is going to cause that as we get the rotation, the current is going to transfer from the capacitor to the inductor and then from the inductor to the capacitor, depending on where we are. Now, in order to determine the impedance, Z is equal to, like we looked at the previous, V total over I total. That's the simplest method to calculate the impedance. But if we do not have those values, then the impedance, which is equal to the total reactance, because it's parallel, we inverse it, that is equal to 1 over XL, wavy minus 1 over XC. And we're subtracting those two to get a positive answer. When it comes to calculating the total current, I total is equal to IL minus IC, wavy minus IC. Remember, subtracting them in order to get a positive answer.